Righto, let's have a look at the next one. So find the exact area of the regions enclosed by the graph y equals x bracket 2 minus x bracket x minus 3 and the x-axis. So first thing we need to do here is we need to get a sketch of the graph so we know what it looks like. I'm looking at this and I'm thinking, well, x times x makes negative x cubed, so the graph is going to have that kind of shape, potentially. We'll assume so. Also, from this I can quite easily calculate the x-intercepts using the null factor law. So x should equal, I'll just write it over here, so x equals 0, x equals 2, and also x is also equal to 3. So those are going to be my key points. At 0, there's 1, there's 2, and then also at 3. So I can draw this now. Okay, it's going to come down from here, it's going to pass through the origin, it's going to turn and go back up. Then it's going to have a small bit above the x-axis before coming back down again and continuing to decrease. We're looking for the regions enclosed between the graph and the x-axis. So that means we're looking for this area here, and we're looking for this area here. And we don't need to worry about any other parts. So those parts are completely enclosed. That means, well, I better write the coordinates. So that's 0, 0, that was 2, 0, and 3, 0. Important to write the coordinates on a good graph. But basically, we're looking for this bit between 0 and 2, and we're looking for this bit between 2 and 3. To make this a little bit nicer, I'm also going to expand that equation out. So I'm going to write in the form y equals, now if I expand that, I'm going to get 2 times x, which is 2x. I'm going to get 2 times negative 3, which is negative 6. I'm going to get negative x times x, which is negative x squared. I'm going to get negative x times negative 3, which is plus 3x. That's x out the front of negative x squared. Now I've got 2x plus 3x, which is 5x, and then minus 6. And multiplying by x, that gives negative x cubed plus 5x squared minus 6x. Now that's a bit easier for us to anti-differentiate. So the area is equal to the antiderivative between 0 and 2 of negative x cubed plus 5x squared minus 6x dx. Now that part is below the x-axis, so I need to remember to make it negative. Then I'm going to add on the antiderivative between 2 and 3 of negative x cubed plus 5x squared minus 6x dx. This is going to be quite a long question. I think it's going to take another video after this one, just a heads up. So let's continue on. That means we need to anti-differentiate, so we get negative x to the 4 on 4 plus 5x cubed on 3, then minus 6x squared on 2, which is just minus 3x squared. Oops. That's between 0 and 2, and that was also negative. Then I'm going to add on the antiderivative, again is negative x to the 4 on 4 plus 5x cubed on 3 minus 3x squared, and this time it's between 2 and 3. So heaps of subbing in to do. We have negative out the front of. Now, this is going to get a little bit messy, so negative 2, well, I'll just do 2 to the power of 4 first, which is going to be 16, and then divide that by 4, which is just 4, and make it negative. Plus 2 cubed is 8, multiplied by 5 is 40, divided by 3, nothing much to be done for that. Minus, I'm going to have to finish this in the next video.